In this video, I'm going to go into a lot more detail on how to use the corridor template editor to build up some surface information relating to a road design. So I'm going to have to create a corridor. Before going into the corridor, let's look at the MSI Manager. This is the library that's used to store information about materials for takeoff or earthworks reporting. This is something that needs to be set up in a template that can be then transferred between other projects. For materials, there are two categories of interest here, earthen and earthen select. So earthen, these would be materials that might be found generally already on site within the project area, and earthen select are materials that would be brought in to build the pavement, road, or whatever surface is being constructed. A corridor requires an alignment on which to form, and there's already an alignment in this project. So when we go on to create corridor, give the corridor a name, check the alignment is picked that I want to use. If I want to reference the OGL, I can pick which is the OGL surface here. I'm not going to reference any additional surfaces, only the OGL. Insert a template at chainage 0, and a template essentially contains the instructions that are used to define, in this case, the road shape. Various layers in the road will be assigned to material layers. I have a number of material layers already set up in this project, inherited from the project template. If there weren't materials here other than finish and they needed to be set up, then there are buttons at the top here for setting up that information. Okay, let's put in an instruction. So I'm going to start with the finish surface. Basically start at the top and then work down. So there'll be a node where the alignment is. This is the starting node. It's always number 1. Instantly we're looking at chainage 0 here, which is only the start of the line is only partially on the surface model. If I move the chainage position along a bit, you can see the surface extending fully across, and this is at well, we'll set it to chainage 5. So node 1 is the starting node where the alignment sits relative to the corridor. There are no other nodes in here yet from which to create the surfaces, but these are about to be entered. There are a number of instructions here that can be used to position additional nodes, and then within the node instructions there are multiple options as well as to how to define their properties and values. I'm not going to go into these in great detail, but just show the overall process and the options. So to put in a second node, you need to specify which node is being offset from. I'm using an offset slope instruction here. So the offset would be the left-right horizontal component. So -3, for example, would be a 3 meter offset to the left of the node, looking in positive chainage direction. And put a slope value in, adding the % annotation will just make sure that that goes in the units that I want. It's possible then to add a name for the node, a reference note if you like. So I'll give it CL for channel left. And this will be used to create the finish grade layer. So having this finish option ticked on is appropriate in this case. Happy with the settings, hit add. And that then is populated out and shown in the graphical editor, and the instruction is added here to the table. As further instructions are added to create additional nodes, the table will be further populated. Of course, it is possible then to go back and edit any of these instructions by going in to the table and changing the required values or parameters. In this workthrough, I'm going to keep the instructions offset slope. I'm going to offset from node 1 again, but this time go out to the right and still with the minus 2.5% slope to give me a channel right node position, like so. So it's a crowned surface that's been defined for the finish grade surface. So I then want to go in and add some subgrades. I'm going to pick a different type of instruction. So from the instruction options available, I'm going to pick the option for offset and elevation. So essentially offset down from the 3 nodes in the finish grade layer. Start on the left. I work from left to right. So I'll pick node 2 as a reference to offset from. So horizontally the offset is 0, but in elevation I'm going to offset down 0.2 of a meter. I'm going to give a node label in this instance. Untick the finish grade because this won't be associated with a surface at this stage. And tap add. Now I've got a node number 4 referenced below the left channel position. I'm going to do exactly the same then, offsetting down from node 1. And finally from node 3. Okay. With those new nodes in position, I'm going to connect them together to form the base surface that I require. The instruction type now will be connect, and it's a case of picking which node to connect from and which node to connect to, and to select the surface material layer that the surface will be built onto. Going back to the reference to the MSI manager and the library of materials that can be stored in there, here I'm browsing the materials in that library, so I'm going to select earth and select asphalt as the material that's going to fill in above the connected points forming this surface and the surface above, which is the finish grade. Hit add and repeat the same going from nodes 5 to node 6. Same material layer surface and same material layer to fill in above. If I want to go further and add a subgrade layer, perhaps top of formation, I'm going to drop down 2 more nodes. These nodes don't need to follow the crown necessarily. You could put a slope on them if a slope was in the design instructions for the road or the corridor. In this case, I'll just keep it simple. I'll go back to the offset elevation instruction, going left to right again, so I'm going to reference from node 2, offset 0 and come down 0.7 of a meter. As I'm just dropping down, I don't want to pick a surface at this stage, I just want to drop and create a new node where I need. Same on the right side, so the offset node will be from 3, and again minus 0.7 is the value required. Okay, so the 2 nodes are in. Can go to the connect instruction. I go from node 7 to node 8 to build the new surface, and that will be on a subgrade material layer surface, and we can add in the material that's going to be filled in above, up to the layer above it. Okay, shown now in the cross-section diagram, or the template diagram underneath. So to remove the chainage slider, we can see how that relates to the road and the OGL. As it happens, this is mostly in cut, but if you wanted to extend outwards and interface the channel strings, just as an example of adding a new instruction to the existing OGL, that can be done by inserting instructions further up the table, or indeed adding them at the end. If an edit is required for any of these, can select it here. A right click and edit will bring up the settings as they were previously, and of course they can be changed here now. But in this instance, what I want to do is just add an instruction, a side slope instruction for the channel strings, so very basic shape. In the entry here, I can just right click, then choose add. So we're going to add a new instruction. And this time it will be a side slope instruction, and it's going to go from node 2 to the target surface of OGL. Do quite a steep slope, 50%, cut ditch width 1, fill slope, again 50%. Auto on the tie direction, and that will be for the finish grade layer and add. Okay, so I've got an additional instruction in here now, as shown in the template view, the graphical view. You can right click and choose add again here to add another side slope instruction, this time from node 3. Same target surface, OGL, cut slope 50%, cut width 1, minus 50%. Those have been added, and we can see actually the shape of the road being formed in the plan view above, as well as the section view below where the template instructions are. Just turn off the OGL here a moment to see that a little more clearly in the view. It's a very simple example here with just one template, which is defining the shape of the road corridor and the surfaces being created all the way along from start to finish. For more complex shaped roads, additional templates would need to be added, that show the shape of the road at those templates as well, and a transition template put in place to transition from one shape to another. However, this video is just covering the basic steps of creating the instructions in the template editor. So I'll close the editor. If a material volume report is required while still on the corridors ribbon, the function to use is corridor earthworks. Make sure the correct corridor is being utilised. Set a chainage increment to base the calculations on, and hit OK. After a few seconds, the report will be generated. The report itself is split across several pages. It's a bit of summary information at the start. Total cut quantity. You can navigate onto page 2, and here's the total cut volume. The amount of asphalt material required in the unit settings defined in the MSI manager, so in meters cubed in this case, and also the volume required of the earth and select base material as well. So this is calculated on a chainage interval basis, so we can see it was set to use 5 meter chainage intervals. So the amount of cut is shown here, which is 26.7 cube. When we go on to chainage 5, we can see the accumulated amount then between 5 and 10 will be 58, so it's adding 31. So from 0 up to chainage 5, the volume is 26.7, and then from 5 going along to 10, it's 58, and then from 10 going along to 15 and so on, it's 89.5. So the amount of material between each chainage interval is shown here, and the accumulated volume is shown at the end column here. The report itself can then be exported to an Excel file type, PDF or Word. Therefore, in this video, I've gone through the process of editing road template information. Find the shape of a road surface with various material layers and fill materials associated with those material layers, and to calculate the amount of material required via a corridor earthworks report.